So you're about to have to calculate something called cell potential. And cell potential is the number that you get off the voltmeter at the top. So this number here, that's cell potential. That's what you get. And it's just basically the difference in the potential of each cell. I know it sounds redundant to say it that way. Now this is related to energy. It's in that we can take cell potential units and we can do some conversions with volts. And as long as we take in consideration how many electrons per reaction are moving, then we can do some calculations and get this in terms of energy. So we know how much energy is coming out. There are some uses though in electrochemistry where it's just much more useful to use the unit volt. So you will see volts, and of course, you know, voltage, batteries come in certain volts. So a lot of times they'll just stop at that unit. We end up doing some conversions into energy though, because in chemistry, we're always interested in the energy of a reaction and whether it's going to play out in finish. So this is what you're going to be calculating, and you get cell potentials. You get each potential in each cell, and this just comes from a chart of values. So you'll see that demonstrated in the next section. It just comes from a chart, and you just have to make sure you pick them in the right spot. So the relationship that brings cell to energy, there's actually a few equations here that will help you do it, but I want to highlight something. Right here, E of cell is related to your good friend delta G, which is a way of us measuring spontaneity. And before we had you calculate delta G, but we didn't actually have you do anything with it. We just were like, well, if it's positive, is it spontaneous? But these numbers with the E of cell numbers actually help us calculate the actual amount of energy. And ultimately, we end up converting the units so that they become kilojoules per mole. And I just want to point out, we're used to the negative G being spontaneity, and that is true. But you'll notice that there's a little negative in that equation. Positive E also means spontaneous. And if you remember, we've already learned this equation with K. We can also relate E to K. And if you remembered, positive K tended to also be a spontaneous reaction. So those are kind of similar in that we can also relate E of cell to K. So you'll be using all three of these formulas. Well, not really this much as much because you've done it before. But you're going to be using these two formulas plus the E cell formula. The E cell formula is really easy. It's just a quick subtraction formula. All the rest of these formulas have certain things in common. So two of these have an F in them, and F represents Faraday's constant. Faraday's constant. So this is just a constant you'll throw in. It's like 95,000, but there's a few more numbers in there that you're going to want to use. N, and we're used to that representing moles, but it's actually specific because we're talking about electrons moving. This is moles of electrons, and it's a certain place that you look for these moles. So if you remember when you're balancing half reactions, you if you had a reaction that had a total of, let's just say we were doing a copper and reacting with a zinc, that reaction actually involves two total electrons that are being transferred, not one. So in that case, the moles of electrons are going to be 2. So again, this is coming back, but I'm just kind of doing a quick little overview of where we're going with E cell. So that's also what this N is. So both of these equations have N, and both of them have the Faraday constant in them. So right there and right there. And then this, we're talking about energy, so that's that R, that's this one, 8.314 joules. And again, you're going to have to be real careful with all your units, making sure that you end up, most of the time, you do ultimately end up wanting to convert into kilojoules. And then your T is going to have to be in Kelvin, just like before. So it's not like new and crazy, but just want to let you know that's where we're going. So you really want to make sure you understand how to calculate E cells. Again, it's really easy, but you want to understand how to calculate it because they're going to be put in the context of some larger equations really soon.